Ladies and gentlemen. Sorry, Ethan seemed like he was laying down a beat for a minute. So we need to dive in, and I'm going to start with homework problems because for a couple of you, you came to me and you tried to ask homework problems yesterday, and I said if it's on tonight's homework, like save it for class. Because if you have that question, your classmates probably have that question also. So I will throw that up on the TV and move this down. So what from your homework, Jalen, were you wanting help on? Jalen. Never mind. Naya's awesome. All right, what else? Guys, right now we should all be double checking that we have our plan book filled in, which you could fill in through Thursday right now if you wanted. It's all, like, if you can read, like if you can see that part. So tomorrow will be 120 to 129. Pick whatever 6 you want. I was trying to pick my own 6 and I couldn't make the choice. Like they're all really good problems. So if you want to do all of them, that'd be a really good refresher for what's coming on the mastery soon. Now that I believe most of us are in here, and please make sure if somebody else shows up, they get one of these also. As we talked about last week with your mastery that you should still have, I don't think anybody in this class turned in another one. This is that follow-up worksheet that I was talking about. So please put your name on it now in case you lose it. But this is what you want to turn back in. Use a handheld one. That doesn't work very well. So look at this real quick. Put your name at the top. Sorry, I didn't make the name line bigger. I just forgot to. So put your name at the top. Notice there are only 7 problems. Yeah. No, so this is the follow-up. So here's what's up. I need your attention on me for a minute. Actually, for like 45 minutes if possible. Because that's how long the class is. So, here's the deal. If you feel as if you showed mastery on the assessment that I gave you back last week and we went over together, you are not required to do this follow-up. You can give yourself a grade of mastery, turn it in, but if I disagree with that, like we're going to have a conversation about why you feel like you showed mastery and I feel like you don't. And I'm not saying like you're going to have to do the follow-up, but like I want to know like why you're thinking what you're thinking. Now, you think that you were progressing, like you didn't quite show mastery, you made some mistakes, you made some errors that you shouldn't have, you didn't know how to solve certain problems, like then you should essentially be honest with yourself, give yourself a grade of progressing, and do this follow-up assignment. You can do it with a partner. You can do it with an 8th grader. You want to ask Naya for help or whoever. You can do it with a sibling or your mom or your dad or with the help of the textbook or your notes. This is an out. I don't know why people are just choosing to talk over me. This is an out-of-class assignment that you can do however you want. So notice, number 1, bunch of addition or multiplication. Number 2, still the same sort of thing, just different problem set because I liked both of them. So I wanted to hit you with a bunch of those. If you're good at those skills now, guys, if you have mastered that, even though there's like, I don't know, 13 of those problems like wham, bang, boom right in a row, they should be fast. If you have mastered working with positive and negative numbers, those should not take you very long. Because normally when I like tell people, there's only 5 problems or only 7 problems, they're like, yeah, but this one has 9. They should take you like 10 seconds. Like not all, but each one, you should be able to look at it, figure it out, and write it down. It doesn't even really take any work outside of that. On 3, that is a 10 by 10 grid, but again, the copier kind of stinks. So one of the lines didn't show up, so I drew it across the middle, but then like when I copied it, most of the lines didn't show up. So 3 columns are shaded. You should be able to figure out how many boxes that would be if 3 columns of your 10 by 10 is shaded. For number 4, you can write your answers wherever, but I have to be able to tell where it goes. If you try to squeeze them into the little grid, make sure you write them clearly so I can read it. Flip to the back. Number 5, same sort of skills as number 4, but rewrite the fractions as decimal and percent. You could either do that work below those, or a separate sheet of paper. As always, you can use separate sheet of paper. 6, diamond problems. You should be really familiar with those. And 7, number line scaling. You should be really familiar with those by now. So, regardless of what grade you give yourself, this needs turned in with your mastery. So when you turn in your mastery, like when you turn it back into me, which could be as soon as today, you need to have this with it. Whether you give yourself a mastery or not, this doesn't necessarily have to be done. If you give yourself a mastery, you don't have to do this. But if you're like right on the fringe and you can't decide, I don't know, did I show mastery or not, you might as well probably try to work through this. And if working through this, you're like, this is tough, you probably weren't mastered on those skills. Right? Be honest with yourself. And if you need help figuring it out, like if you can't make that determination, come see me. Most of the time, you guys are harder on yourself than I even would be. Like, I might have given you a mastery and you gave yourself a progressing, like, which is okay. You want to, like, push yourself to be better. Riley, what's up back there, dude?
I'm looking for something.
The mastery I'm talking about?
Yeah.
The one that I said, if you think you're going to lose it,
the
don't.
paper you just gave me and I accidentally put it in here.
Here, I made extras. Do you know where that mastery is, though?
Yeah, I know where it is.
All right, so now we got to move on, so please put that away. I do not want to see that out again today in class, because obviously you could be working on it right now, but that's not what we're doing. Hi. And then what do we need out? Graph paper. Any questions from last night? Last call for it.
Yes.
Aiden.
So my first question is obviously on D-94 with A.
Okay.
With A and C. I always get confused when you're doing division of just like normal division across, or if you're doing a negative times a normal, and if it's not like a negative, like a big number, like a big negative with a whole number.
So remember, we're doing KCF. So to start you off, we end up not doing division because we switch it to multiplication. So are you clear on that, of how we switch it to multiplication to flip that second fraction? So that's A, right? A turns into 3/4 times 6/1. I'm doing an easy one to start. So then I go straight through the top, 18, straight through the bottom, 4. Now C is going to be a bit more challenging. Hopefully we'll have the homework written down. If not, it's over there, but that's about to disappear. That's really loud. C, when we turn it into multiplication, and we know division operates under the same rule set as multiplication, but when we turn that into multiplication, it becomes -2/3. And remember, we said yesterday, where this negative is doesn't matter. If there's one negative, the value's negative, times we flipped the second fraction, and then go straight through. So Aiden, if I say that this negative belongs on that 2, then straight through the top, I get -4. Straight through the bottom, I get +3. This fraction value is still negative because there's one negative involved. I could put it on the 4, I could put it out in front of the fraction, or I could put it on the 3. But I got to pick one spot for it to go. Other homework questions? Aiden?
This is the last one I have. It's on 3-95.
Okay, we can continue.
I got A, but B and so B and C. Well, C was actually the lowest, right? But B, like how, like when you represent the problem with multiplication, because when you like make the grid, it's like this.
So 1/3 of a rectangular playground is for young children. So we'll say right here, that's our young children, right? Then 2/5 of that structure is covered with, or of that space is covered with a play structure. So if I divide this into 5, and then these, 1 and 2, so you said B or C is where it's goofing you up?
So C. Yeah, C.
So B, if we write out the multiplication, 1/3 times 2/5. C, what fraction of the total playground is the play structure? So this is the only region that the play structure is in. Apparently, now sometimes we shade all out here. But if we just look at this section, how many sections of 2 out of a total of 15? So this answer to B is C. Because B just says set it up with multiplication. C is like, what's the answer? So yeah, this 2/15 is your answer to C. Anything else? Moving on to our lesson for today. We are still working division, but now we're going to talk about division with decimals.
Oh no.
Why?
Oh, decimals.
Okay. So, what if I can turn every decimal problem that we're talking about into not having decimals and having whole numbers?
That'd be a miracle.
That'd be better?
Yeah.
All right, I'll make that happen. So, Ava, in her true, honest self, which I love, says division with decimals is tough. But you're the one who. Division with decimals is tough because they're partial numbers. Anytime we're working with partial numbers, it's tough. So I have promised Ava I will make this easier. So if we jump right over to 98, Mr. Garcia is trying to cut some 9-inch spacers. What he's working with is a board that starts with 16 feet of length. Or he's got a 16-foot board. He wants 9-inch spacers. I want you guys as a team to figure out how many spacers would he be able to cut from a 16-foot long board when the spacers need to be 9 inches. I'll give you about 2 minutes probably to work on this. I will warn you, there's a trap door here.
How many foot is it?
We can set this up with division. This is 3, 3, 2. Just right out here, put like 3, 3, 2 or something like that. Can anyone tell me what the trap door is? Oh, you could. Labiba, do you know what the trap door is? 16-foot long board, 9-inch long spacers. Be careful, the units don't match. We cannot just do 16 divided by 9. That doesn't work. So take like 30 seconds or a minute more, talk with your team, figure out if you can determine a way we can solve this. And by the way, just because I have to determine this, I was realizing as I was sitting up here just thinking, those masteries need to be back to me by Friday. Okay, so like today's Tuesday, right? That mastery follow-up, that and your mastery, if you're turning a both or whatever, like that stuff needs to be back to me by Friday so I can put something in math. So if you've lost it or whatever else, or if you don't turn it in by Friday, it'll go in as a missing. Jump on your Bible when I'm talking. Can you realize what that's like? So, I heard a lot of groups saying we need to convert something. We need to change inches to feet or feet to inches or whatever. And to do that, we need to know how we convert. Can anyone help me convert? Eva, how do I convert this? Yeah, the easier option is go to smaller units. You might want to write this down as a small note in your notes. It is easier to convert to smaller units. Feet are bigger than inches. So let's turn 16 feet into inches by taking 16, and here's why. We put 16 feet over 1. Then we multiply by 12 inches per 1 foot, and the label of feet on top and feet on bottom cancel each other. Anything over itself, right, reduces out and disappears. It turns into 1. So, like Eva said, all we really have to do is 16 times 12. Break it up. What's 16 times 10? 160. What's 16 times 2? 32, right? Put them together, 192 inches. So we did 16 times 10 was 160, right? If we just try to break this up in our head to make it easier, 16 times 2, although I went off the screen, was 32. So if we put those together, we get 192. So then to solve this, 192 divided by 9, since we have matching units. What's your approximation? About 21, right? Because 29s would give us 180. Another 9 gives us 189. So approximately 21. Now Sloane's a moaner. He just complains about everything, like a few of you in this class. So Sloane's like, ugh, such big numbers. Gross. He doesn't like big numbers, right? So Sloane says, 9 inches is actually 3/4 of a foot. So Sloane sets up this, 16 divided by 3/4, because he decides to turn the inches into feet. So go ahead and write this on your paper. This is a complex fraction, because there's a fraction in a fraction. So make your 16 bigger than your 3/4. And actually, I'm probably going to switch screen places. Be careful, 8 is 2/3. So think about it. Here's what Sloane does. Sloane says 9 inches over how many inches in a foot? 12. 9 over 12 reduces to 3/4, because they can both divide by 3. Right, so that's how Sloane gets his 3/4. So then he sets up 16 divided by 3/4, or we could write that out. 16 divided by 3/4. What will make this setup better? And we should have been practicing this on our homework last night. Because right now I don't have fraction. Yeah. Yeah. Put a 1 under the 16, and then what do I do? Keep going. Ooh, I don't like division.
Me neither.
We gotta keep change flip first. So this becomes 16 over 1 times 4 over 3.
I totally agree with you, Mr. Hudson. Division is annoying.
Division is annoying. If you want to split this up, 10 times 4, sorry, my brain got confused. 10 times 4 is 40, and 6 times 4, 24. So I think we get 64 over here, divided by 3. How many 3's can fit into 60? 20 of them, right? Then bump 1 more, 63. So I get 21 and then 1/3 left over. And that is how many spacers. Right? He's making maybe they're like to go inside of a wall. You got to put spacers in to keep it rigid. Question. This is just review of our skill from yesterday of division with fractions. Yeah, but don't like run. Run.
As fast as you can. You can't catch me on YouTube right now.
So, here's a question though. Hold on, so that's what we did yesterday, right? Hold on. Hey. Hey guys. I don't know what you have to talk about that's so important, but now we're moving on to the new stuff, so it would behoove you, which means benefit, to listen right now. So, Sloan forgot how to do what we did last night. That's his name. I have a friend in high school whose name is Sloan.
It's a her.
Okay, sorry. My friend in high school was named Sloan, and he was a male, and he was a great football player. So sorry, that's where my brain goes. So Sloan writes it like this. Okay, 3/4 is 0.75. Do we agree 3/4 is 0.75?
Yes.
And do we agree that 0.75 can be written as 75/100ths?
Yeah.
But when Sloan does keep chin flip, you don't have to write anything right now. I just want you to watch up here. Sloan ends up doing 16 divided by 75 over 100, which then becomes 16 over 1, right, like Isaac told me to do. Change, flip, and this becomes 1600 divided by 75. Now, wait a minute. What happened between my original fraction and the fraction I have now? Sky, can you explain that in another way? If none of this stuff in the middle exists, how would we go from this fraction to that fraction? Yeah! So now, please go ahead on your paper, write down 16 over 0.75, and put that 0 there just to make it clean. Do not write this stuff in the middle. Do not write this. But what you do want to show is if we multiply by 100 on top and bottom, I've now done what Ava wanted. Ava doesn't want to divide by fractions. I agree. Ava doesn't want to divide by decimals either. I agree. I only really like multiplying, but if I have to divide, I would like to divide with whole numbers. 160 divided by 1,600 divided by 75 is the same exact thing as our starting fraction. All we did was multiply by 100 on top and bottom, which we know doesn't change anything. Right? It looks different, but it is the same. Questions on this? So, what if you go down to problem 100? What? So I'm capturing it, but it's just not up on the TV right now. I'll put it up on the TV in just a second. No calculators, check out 100. See if you can figure out the easier way to do that. So it's set up with long division, which is just I'm allergic to long division these days. No, you don't. You think you do, but you don't.
I hate long division.
It's up on the TV, but I'm using my screen right here.
I get it wrong every time because I never learned how to do it.
Now here's what I'm worried about, coming back from long division.
I never learned how to do long
In the old days, hang on. In the old days, we would place our decimal here, right? Which I think would also make my decimal go up here. And then I got to put zeros out here. But how does this decimal come into play? Okay. I don't really know what to do with it. Guys, I'm actually being honest here. Like, if I'm talking about what I'm confident with, I'm not confident at all setting this up. However, I don't have to long divide. Jalen?
You move decimal point in the 0.5 to the right, and then you also do the same with the 16.
If I don't know what to do with that decimal, what if I just bump it over to the right and I do the same thing here, and now instead I have 160 divided by 5. Now I know that my decimal comes straight up here. How many 5s fit? Well, how do we do this? Sky?
You see how many 5 goes into 1, which means none. You can't do that.
Okay.
0.
Okay, so 0 here, or we just kind of move on.
Yeah.
Then how many 5s fit into 16, I guess we're dealing with? 3. And then we got to do this work. How many 5s fit into 10?
It's so 32.
Oh, answer's 32.
I literally just, no, what I did is I counted, so it goes 50 plus 50 equals 1. So just do 5. I did 5.
Mhm.
So I did 1, 2, 3, 4, 5. Like that's.
I'm with you. Yeah, yeah.
I did not need to do that. That's so fun.
Or, because I'm like allergic to long division.
Me too.
Now, here's the thing that actually I've realized 7th graders aren't that comfortable with. In a long division problem, this is on the inside of the division, and this is knocking on the door to get in. Right, this is how I remember it. No joke, this is how I remember it. The inside value is your numerator. The one knocking on the door is your denominator. Right? Numerator's inside, he's numerator. This value's outside, it's knocking on the door, it's the denominator. So when I go to turn this long division setup into a stacked fraction, or vertical division, however you want to explain this, that is how we figure out which goes where. Inside gets numerator. Yeah.
So wouldn't that be 3.2 for the original?
It's actually still 32. Because think about how many halves can fit into 16 wholes. Like if I have 16 pizzas, how many halves can I get from those 16 pizzas? Well, if I give you half, I can get 32 halves. So that's the thing. This answer up here would still be 32. But it's complicated to get there because we don't really know what to do with this decimal. This is just a gross setup. We want to work with whole numbers. So try 101. We're going to give you a bit of time to practice this. Try 101. Set it up however you want and then solve it in whatever best way you feel. Then converse with your team. So we're going to walk around, Mr. Smith and I, and we can help you if needed. You can use a calculator for these, but I would encourage you to try it without a calculator first.
I actually never went to do it on this.
We can. 3 divided by 4, just 3 on top of 4. You actually kind of probably should have that one memorized.
That's how I have to write. Oh!
So you are writing out the numerical, and then you're going to write down the answer. If you can do it in your head or on your paper, sweet. Otherwise, you can use a calculator. Like, you may use a calculator here. It's telling us directly we may use a calculator.
So you have it for 1.
3/4. If you have 3/4 of something, what percent do you have if you have 3/4 of something?
75.
So what decimal is that?
0.75.
There you go. That's your answer.
Oh, that makes sense. I still hate the machine. That makes more sense.
I said I think.
Where did my physical
Use this for now, dude. Is there a what? Is there a case? I have no idea. Probably. I have no idea. Hopefully we know 3/4 is 0.75. That's one that we should probably have in our head. But if I look at 1.5 divided by 0.25, now guys, a really easy way to think about these problems is money. If I have $1.50 and I want to know how many quarters that is, right? $1.50 divided by 0.25, or if I want to take an AVA method and get rid of those decimals, we can bump them both to the right 2 places. Well, I'm making it called the AVA method now. Now my decimals here and here, how many 25s and 150s? I get the same answer no matter what. 6. What? Now what about 15 divided by 2.5? Here, I mean, I can. There's another one too. I'm not sure. Hold on, Brandon's got something good to say.
Is it like division where it would be 1.5 times something equals 0.25?
No, it's that the bottom times this equals the top. So the multiplication that like checks this is denominator times your answer equals the numerator.
So if it was the other way around, it wouldn't make sense.
Now I am short on time, so I'm kind of like spoiling some of the potential surprise that you're supposed to see here. If I compare B to C, well, B has 1.5, C has 15, so the decimal location is what's different. Right, but this has 0.25 and 2.5. Are we going to get a different answer in C? No, it's the same problem. It's 6.
And then that's
If we look at D, who can tell me what's up with D? Isaac, what's up? With D? You had that smile on your face that made me feel like you knew. Okay, Natalie, can you tell me what's up with D? Ready? It's the same thing as A. It's just 3/4. These stacked zeros don't matter. It's still 0.75. You with us, Casey? What about E then, Casey? What can you tell me about that? Guys, there's a lot of side conversations. I only have like 5 minutes left. We need to use this time. Casey, what about E? It's gross because all those decimal places, right? How far should I move the decimal to try to turn? Yeah, 3 places, right? So if I go 1, 2, 3 there. 1, 2. Wait a minute. This is 3/4. It's the same thing that we just had. What about F? Why, Isaac? How far?
Two. 3.
Up here it would only need 2. But down here, we need 3 places, so the denominator and the numerator have to do the same thing. I gotta put an extra 0 on here, but that comes out to be 150 over 25, and exactly what Isaac said, it's the same thing. Guys, here's what we're trying to get you to see. If you take a moment to manipulate the problem before you start. Ava doesn't want to divide by decimals because it's annoying. I agree. So change it. Fix it. Whatever you want to say, make it better so the work is easier. Look at 102.
The evil 102.
Set this up. Be careful. Eloise is just starting this skill also. 700.07. This should be going on your paper. 0.07 divided by 0.4. .07 divided by 0.4. Solve it out on your paper. Eloise wonders, can she just do 7 divided by 4?
No, she can't. There's an extra step she has to do after that. No.
Well, then should we really do that?
No.
Should we just do it the right way?
Right way, which is hard to do though.
Alright, so Ethan said something interesting. He said, well, we could do what Eloise is asking, 7 divided by 4, but then there would still be another step. I said, well, then is it really a good idea? And he's like, well, no. So, Ethan, what should we do instead?
You should make them both whole numbers
How do I do that? How far do I move the decimal?
over 2 places.
2 places, right? If I drop that there, 1 place, and I got to add a 0 down here. So this is going to be 7 divided by 40. I can't just do 7 divided by 4. You got to do 7 divided by 40.
And that's 5.
Which we don't need to answer. We were just checking out what
What
happened.
equals 7?
Questions? Take 3 minutes on your own. Try 103. No talking. On your own. Try 103. Turn those first into integers, no decimal places, no fractions, integers. Then do the division. 3 minutes, just on our own. I'm going to give you a 2-minute head start. No, I like it. Guys, why are some people like not doing anything? What are you thinking about? The next fashion challenge? You're not doing math. Don't lie to me.
I'm thinking about the problem.
should be what you have after at least your first step. We get rid of the decimal places. We got to do the same thing top and bottom. So if I move 2 places down here, I got to move 2 places up there, causing me to add in that extra 0. And then I can solve that pretty easily. Right, that's just 10. Right, how many 25s are in 250? My second one, I can still move the decimal pretty easy, but the division isn't quite so easy. Right, so how many 70s? Well, first off, ask yourself, is the answer to what we're doing here going to be positive or negative? Negative, right? 1, negative. Do that first. Always do your sign first. And then it's like 1 and some stuff left over, like 1 and 42, I believe, 70s, 70ths.
Wait, I have a question.
Yeah.
How would 559.1 equal 591 when 2.5 equals 291?
Because down here, we only moved the decimal 1 place in each of them. Up here, we went 2 places, causing us to put in that extra 0. This is actually really easy. Give me your eyes for 30 more seconds. How many 3s would be in 600? 200, right? How many 3s do I need to take away 9? 3 3s, right? So this would be 197 3s would make up that. No, it's actually just exactly 197. Please try your homework and bring me questions to class. I have yet to decide if we take a test on Friday or not, but the more actively involved in your homework you are, the more likely I am to actually push it to next week. Because I know you're really engaging in the work and asking questions, I will wait for an assessment. Have a wonderful day, guys. Get outside this evening. It's going to be nice, but the next couple days are going to be cruddy. No, I would wait. If you have questions, I would rather wait, but it also tells me that you're actively doing your homework. But if I know that you guys have questions, that's fine. But then you're probably ready for the test, right? If you don't have any questions, you're probably ready.